continuing on with lesson 1.1, where we're continuing to find limits, I want to work on an example finding it numerically. Now that's going to involve using a table of values to see what happens as we approach some numbers. And this case, I'm not going to use a graph, I'm going to use a function. In this case, I've got this piecewise function. Notice we call it piecewise because we've got three different pieces here. So we're going to use the absolute value of x as long as x is less than or equal to -2. We're going to use x squared if x is greater than -2 but less than or equal to 2. And we're going to use 3x minus 2 if x is greater than 2. So here's what we're going to do. I'm going to use some algebra skills again to review those, where we plug in some numbers and see what happens. And the other thing I'm going to do is use that kind of idea on calculus as well. So here's what we're going to start with. We're going to start off by saying, what is the value of the function g at -2? Well, if I notice up here, x is less than or equal to -2, I need to plug into the top piece. I need to plug into the absolute value of x. So I'm going to plug in -2 into the absolute values, and I should get +2. Okay? Again, we had to plug into the top one because our x was less than or equal to -2. It was -2. For the other one, it says g of 2. So I'm going to come over here and I'm going to look and says, okay, it's not less than or equal to -2. However, it is greater than -2 and less than or equal to +2. So I'm going to plug it into this middle one, which is x squared. So we're going to do 2 squared, which is 4. All right. The only reason I would use this top one would be this bottom one, the 3x minus 2, would be if I was using an x greater than 2. Okay, since I didn't use an x greater than 2, I didn't have to plug into the bottom one. Now, I'm going to switch over and look at some calculus now. Again, these were just plugging into the function, got that down. What I'm going to do now is try to figure out these limits using numerical method. So I'm going to make a table of values. So we're going to look at the limit as x approaches -2. So let me try plugging in some numbers here and see what happens. So if I want to figure out the limit as x approaches -2, I want to use some numbers that are both smaller than -2 and some numbers that are bigger than -2. All right? So I'm going to try to think of some numbers smaller than -2. Let's try -2.25. Let's also try -2.1. Let's also try something like -2.01 and see what happens. For some bigger numbers, I'm going to use the other table. I'm going to start just a little bit bigger than -2. Let's try -1.99. And let's keep going up. Let's do -1.9. And the next one I'll use is -1.75. All right, now that I've decided on what values I'm going to plug in here, I'm going to start trying to use my calculator now. So these values that are less than or equal to -2, they're going to go in the top part. So we're going to do the absolute value. So the absolute value of -2.25 is +2.25. Again, we're plugging into the top on the absolute value. So the absolute value of -2.1 is +2.1. And the absolute value of -2.01, it's an absolute value, is +2.01. So it looks like in this case, we seem to be increasing, actually it's decreasing. We seem to be getting closer and closer toward a +2. Let's try the other one and let's see what happens. So on this one, I've got numbers that are just ever so slightly bigger than -2. So I'm actually going to plug into the x squared part. So we're going to do -1.99 squared and see what happens. I got my trusty little calculator here that I'm going to use. Make sure you put the -1.99 in parentheses, otherwise it won't give you the positive answer that it's supposed to be. I got 3.9601. Let's try -1.9. I got 3.61 when I squared it. And if I square -1.75, I should get 3.0625. Now, if I'm looking this way, if I'm getting closer and closer toward -2, I seem to be actually increasing 3.0625, 3.61, 3.961. I seem to be increasing toward a +4, not a +2. So while this one is decreasing to positive 2, this one is increasing to positive 4. Since these two are not the same on both sides, this left side goes to 2, the right side goes to 4, I'm going to say that this limit does not exist. Now I'm going to try the other one and see what happens. Again, I'm just going to make a table of values. So I'm going to make a different table of values so I don't get myself confused. I didn't need that parentheses there. So this time I'm trying to find the limit as x approaches 2 of g of x. So here's what we're going to do. We're going to plug in some numbers smaller than 2, and we're going to plug in some numbers bigger than 2. So let me think about some numbers smaller than 2. Let's do kind of what I did before. 1.75 is smaller than 2. Let's do 1.9, and let's do 1.9 now. Now, trust me when I say you can keep plugging in numbers and seeing what happens, because trust me, the more information you have, the better off you are. It gives you a better idea of what's actually happening. I'm only plugging in a few numbers because I kind of already know what's going to happen, especially since these are pretty straightforward functions. This first one's an absolute value, the next one's a quadratic, and the last one's a line. So let's see. I'm going to try to do the next one. The limit as x approaches 2. We said that's the left side. I'm going to do the right side, kind of do the same thing. So I guess I'll start with 2.25, then I'll do 2.1, and we'll do 2.01. So left side, right side. So I'm going to plug these numbers in. Now, since these are less than or equal to 2, these are going to get squared. Since these are greater than 2, these are going to go in the bottom one, which is the 3x minus 2. So I'm going to square these. So 1.75 squared, we'll do 1.9 squared, and we'll do 1.99 squared. Again, type these in the calculator. Hopefully it shouldn't be too big of a deal for you to figure out that that's 3.0625. That one's going to be 3.61, and that's going to be 3.9601. Again, notice we seem to be increasing towards the number 4. And like I said, I can keep plugging in numbers and seeing how close we get. We can do 1.9999, so there's 3 nines. But eventually you're going to realize you're getting closer and closer to 4. On the other side, I'm going to do this 3x minus 2, because again, notice these values are greater than 2, so we're going to plug these in and see what happens. So I'm going to plug in 3 times 3 times 2.25 minus 2. Just to make sure I get the right number, I got 4.75. Let's plug in 1 and see what happens. Or excuse me, 2.1. 3 times 2.1 minus 2 gives me 4.3. Let's try this last one. 3 times 2.01 minus 2. I got 4.03. So it appears like this. So if I'm going from 2.25, 2.1, 2.01, as I approach 2, I'm also going to a positive 4. It seems to be decreasing in this case. So this case, they both approach the same number. They're both going toward 4. So I'm happy to say that that limit does exist, and it happens to be the limit as x approaches 2 of g of x is 4.